Alright. For eigenvalue eigenvector, say you are given a matrix A. So we have what? A to be equals to what? Lambda times the identity matrix. Right? So if your A is equals to lambda times identity matrix, so you can then say that what? A minus lambda times identity matrix is equals to what? 0. Right? Is equals to 0. So then if you are given another thing to find, alright, so we have A minus lambda I is equals to 0. Right? A minus lambda I multiplied by x is equals to what? 0. So say your say lambda to be equals to what? Our eigenvalue. A is equals to what? Given matrix. A is equals to given matrix. Our I is equals to what? Our identity matrix. I is identity matrix, and X is your eigenvector. X is your eigenvectors, alright? Yeah, lambda I is equals to 0. A equals to lambda I is equals to 0. That's it. So what we are applying, that's simply what we are applying. So for eigenvalue eigenvector, we can apply it to 2 by 2 matrix. We can apply it to 3 by 3 matrix also. Alright. So let's take example. Example 1. Example 1. 4, 2, 1, 3. A is equals to 4, 2, 1, 3. Say our A to be equals to 4, 2, 1, 3. Alright, are we together? So this A is our given matrix, alright? So we have our given matrix to what? 4, 2, 1, 3. So identity matrix for a 2 by 2 matrix is equal to what? 1, 0, 0, 1. Note that identity matrix for a 2 by 2 matrix is what? 1, 0, 0, 1. Alright? So yes. So therefore we can say that what? Our A is what? 4, 2, 1, 3 minus what? Okay, minus lambda, then we have what? Our identity matrix to be what? 1, 0, 0, 1. Are we together? So therefore we can say that what? Okay, it's equals to 0. Alright, thank you. So we can say that what? 4, 2, 1, 3 minus lambda 0, 0, lambda is equals to 0. Are we together? Multiply this minus lambda times each of the value we have inside. So minus lambda multiplied by 1 is what? Minus lambda. Alright? Alright. So lambda multiplied by 1 is what? Lambda. Lambda times 0 is what? 0. Lambda times 0 is what? 0. Lambda times 1 is what? Lambda. Alright? So we can, from our idea of matrix, the addition and subtraction of matrix that I took earlier. So we can boss abeg. So we can say that what? 4 minus lambda 2 minus 0 1 minus 0 3 minus what? Lambda is equals to what? 0. Are we together? Are we together? So therefore we can say that what? 4 minus lambda, 1 minus 0 is what? 1, right? 2 minus 0 is what? 2. Then we have what here? 3 minus lambda to be equals to what? 0. So therefore what can we do here? We can do the determinant, alright? So that will be what? 4 minus lambda 3 minus lambda minus 2 times 1 is what? Minus 2 is equals to 0. Are we together? Okay, let's say 2 times 1. Are we together? Are we sure? Alright. So 4 times 3 is what? We can expand, right? 12. 4 times minus lambda is what? Minus 4 lambda. Minus lambda times 3 is what? Minus 3 lambda plus lambda square minus what? 2 is equals to 0. So we can simply rewrite and say that what? Lambda square minus 4 lambda minus 3 lambda minus 12 plus 12 is equals to 0. Rewriting. Alright. So that was lambda square minus 7 lambda plus 10 to be equal to what? 0. So this is a what? A quadratic equation. So we can then solve quadratically. Alright, we can then solve quadratically. If you want to solve quadratically, you can use different methods, we know. So if you want, you can use your calculator and get your step direct. If you want, you can use your what? Your almighty formula. You can use what again? So you can use different methods, alright? Just arrive at your answer. So we know that what? Factorizing. I thought someone was calling me. Factorizing, we have what? So when we factorize, what will it give us? Lambda square minus what? How do we come about minus 2 minus 5? Look for two things that are going to multiply. Alright? If you multiply it, it will give you this 10. If you add or subtract, it will give you what? Minus 7. That will be what? Minus 2 lambda minus 5 lambda plus 10 is equal to what? 0. So therefore, you can say that what? Lambda square, okay, lambda in brackets, lambda minus 2 minus what?
Minus 5.
In bracket what? Lambda minus 5. Okay, lambda minus 2, sorry. Is equals to what? 0. Are we together? Are we sure? So therefore we can say that what? Lambda minus 5 and lambda minus 2 to be equals to what? 0. Lambda minus 5 equals to 0. Lambda minus 2 is equals to what? 0. So lambda can be equals to what? 5. And lambda can be equals to what? 2. So therefore we can say that this should be our what? Lambda 1 and this should be our what? Lambda 2. So what's this? What have we gotten up to this extent? These are our Eigen values. So we've gotten our Eigen values. Alright? So therefore what do you want to do next? You want to get your what? Eigenvectors. Alright? So to get your Eigenvectors, so what do you do? What do? You simply say that what? You go back into this. Okay, you say that what? For lambda 1 is equals to what? 5, right? Lambda 1 is equals to 5, right? So you can say that for lambda 1 equals to 5, 4 minus lambda, write back this equation. 1, 2, 3 minus lambda to be equals to what? 0. Therefore we can say that what? 4 minus 5, 1, 2, 3 minus 5 is equals to what? 0. Alright? Are we together? Yes. Is equals to 0. So therefore we can say that what? Minus 1, 1, 2, 3 minus 5 is what? Minus 2 to be equals to what? 0. Are we good? Yes. Alright. So therefore, when you get to this step, you are now going to input what? X and Y. Alright, X and Y. In some other cases, some people use what? X1 and X2. But to avoid errors, or maybe if you know you are good with it, you can use X1 and X2. But we'll be using what? X and Y. That was multiplied by what? X, Y to be equals to what? 0. Reprint. I said you should introduce your variable X and Y. Well, It is because I'm writing it step by step, step by step. So okay, what do we do next from this extent? We can multiply this row 1 by this what? Colon. Right? This is simply multiplying a what? A 2 by 2 matrix by what? A what? 1 by 2 matrix. Alright? So that's it. So we can say that what? Minus 1 times x is what? Minus x. 2 times y is what? Plus 2y to be equals to what? 0. Equation what? Equation 1. Then the next one is what? 1 times x is what? X. Then minus 2 times y is what? Minus 2y to be equals to what? 0. Equation what? Equation 2. Alright? Are we good? From this extent, I said you should introduce x and y. Introduce x and y. Right. And the idea of x and y is that I wrote something from this. 1a lambda I times x. So this one, it represents this x and y. Don't be. No. So from here, you can say that from equation 1, minus x to be equals to what? Minus 2y. Am I right? So therefore, we know we cannot leave it as minus at the front. Minus x is equals to minus 2y. So you can multiply both sides by what? By minus. Minus times what? What we have here and here. That will be what? X to be equals to what? 2y. Look at this. So from here, we can simply say that what? Since our x is equals to 2y, it is logical. X can be equals to what? 2. Y can be equals to what? 1. Are we together? It's simply saying the ratio of x and y. Right? Our x can be equals to what? 2, and our y can be equals to 1. If our y is equals to 1, x can be equals to what? 2 times 1 is what? 2. We say that x is equals to 2. So if our y is equals to 1, x will be equals to 2. Right. So when we get here, we do something logical. So from here, since your x is equals to 2y, you can assume that your y is 1. Assume that your y is 1, right? Because x can now be equals to 2 times 1, which is x is equals to 2. Assuming it's 4, you still assume that your y is 1. And you start from that place.
What if x now coefficient?
X has coefficient. You are going to divide it now. You are going to divide it.
But you just make x stand.
I understand what you are saying. If you have 2x is equals to what? Maybe y abi. So you can simply say that divided by 2. Divided by 2. X can now be equals to 1 over 2 times y abi. S is equals to 1 over 2.
X must not be.
Yes. So so oh yeah, listen. From here, right? From here. So I start from here. No, yeah, let me start from here. So from here we have what? Our lambda 1, which is our eigenvalue 1. Input your eigenvalue 1 into this equation back. Alright? So if you are inputting eigenvalue 1 into this, we can have what? If we have our eigenvalue 1 to be 5, so now input that what? Eigenvalue 1 into this place. So 4 minus 5 is what? Minus 1. Then 2, 1, and 3 minus 5 is what? Minus 2. Alright? So from here, I now said we can then we can introduce, alright? We can introduce our what? Our x and y. So in some cases we can use x1, x2, right? It depends on what you want to use. So then multiply this by what? Your x and y. So minus 1 times x is what? Minus x. Minus 1, I mean 2 times y is what? 2y. You add them up. Is equals to what? 0. Then the next one. 1 times x is what? X. And minus 2 times y is what? Minus 2y. Is equals to 0. Equation 2. Alright? Are we good? Yeah, we use the row to multiply the colon because it is 2 by 2. No, we are going to use the second one also. Yes. That's why I said for lambda 1. So do we get this part? Alright, so then we can move on to what? Alright. Sorry. So now let's do for, this is for lambda 1. Okay, minus x. We have the first equation to be minus x plus 2y is equals to 0. Abi. Then the second equation to be what? X minus 2y is equals to 0. Alright? So I now said we can pick either of the two equations. You can either pick equation 1 or equation 2. But you have to state it that from equation 1. Alright? If you are picking equation 2, state it that from equation 2. Alright? From equation 1 now, we can have it that what? Minus x plus 2y is equals to 0, Abi. So minus x plus 2y is equals to 0. Take y to the other side of the equation, it will turn to what? Minus 2y. That will be minus x is equals to minus 2y. But we cannot leave our answer as minus x because we still have what? Invisible one there. We still have invisible one there. Alright? Because if it was minus 2 you have here, minus 2x, can you see that we cannot use it? So it's still the same thing applied. So that will what? Minus x is equals to what? Minus 2y. So I now said multiply both sides. Actually it is minus 1. Multiply this side of the equation by minus 1 and multiply this side of the equation by what? Minus 1. Are we good? Are we good? So then or you should either divide both sides by minus 1. Right? So then we can say that what? Our x is equals to what? 2y. So we can assume that our y is 1. Then our x will be equals to what? 2. So for lambda 2 is equals to what? Is equals to 2, right? Hello. Listen, this is still recording. Alright. So for our lambda 2 is equals to 2. What do we have? So that will what? 4 minus lambda, which is 4 minus 2. 1, 2, 3 minus 2 is equals to 0, right? So therefore 4 minus 2 is what? 2, 1, 2, 1 is equals to 0. So we can then say that what? We can introduce our x and y, right? 2, 2, 1, 1. X, y is equals to 0. That will be what? 2x plus 2y is equals to 0, equation 1. X plus y is equals to 0, equation 2. From equation 1. So like I said, you can use equation 2. It depends on what you want to use. From equation 1. Okay. Here now, even if we use equation 1 and equation 2, we are still going to get the same answer. So from equation 1, we can say that what? Or let's use from equation 2. Let's use 2. So we can say that x to be equal to what? Minus y. We can say that what? X to be what? Minus 1. Y to be what? 1. Do you get it? So that's our final answer. And this will be our what? These are our eigenvalue. These are our eigenvalue. Now these are our eigenvectors. So that's simply it.